What if I told you your eye color is not just about how you look, but a genetic record of where your ancestors survived, how they adapted, and what your body is still optimized to do today? Look into a mirror for a second. Those eyes staring back at you, they are older than your language, older than your culture, older than most of human history. And hidden inside them is a story that most people never learn. Because your eye color is not random. It is biological strategy. It is evolution, frozen in your DNA. And once you understand what it means, you will never see yourself the same way again. Let's start with the most common and the most powerful. Brown eyes. Over 70% of all humans on Earth share this trait. And that is not coincidence. That is dominance. Brown eyes are packed with melanin, a pigment so powerful it acts like built-in armor. It absorbs up to 90% of incoming light, not reflects it, not scatters it, absorbs it, which means if you have brown eyes, your vision is naturally protected against intense sunlight, glare, and ultraviolet radiation. Thousands of years ago, this wasn't just helpful, it was survival. Early humans lived under harsh equatorial sun, where exposure could damage the eyes over time. But brown eyes created a natural filter, a shield, a biological advantage. Even today, people with brown eyes often experience less light sensitivity, better contrast in bright conditions, and more stable visual clarity outdoors. But here's something most people don't notice. Brown eyes are not just brown. Under certain lighting, you may see gold, amber, even reddish tones. That's not your eye color changing. That's light interacting with layered melanin, revealing depth most people overlook. Now, let's move to something far more mysterious. Blue eyes. Every single person on Earth with blue eyes can be traced back to one common ancestor. Somewhere between 6,000 and 10,000 years ago, a genetic mutation occurred. A single switch in a gene called HERK2, and that mutation didn't create blue pigment. It did something more interesting. It turned off brown. Blue eyes are not blue because of color. They are blue because of absence. There is almost no melanin in the iris, so when light enters the eye, it scatters. Shorter blue wavelengths bounce back out, just like the sky. That's why your eyes can look icy blue in one moment and almost gray in another. But here's where it gets fascinating. Why did blue eyes spread so fast? In some parts of Northern Europe, up to 90% of the population developed blue eyes in just a few thousand years. That's incredibly fast in evolutionary terms. Scientists have two main theories. First, low light adaptation. With less melanin blocking light, more light reaches the retina, which may have helped people see better during long, dark winters. Second, attraction. Blue eyes were rare, unusual, striking, and humans are drawn to what stands out. So over generations, people selected for it. Not consciously, but biologically. Now here's the twist most people don't know. Some of the earliest humans with blue eyes still had dark skin, which proves something important. Eye color and skin color did not evolve together. They followed different paths. Now let's go even deeper into rarity. Gray eyes. Less than 3% of the world has them, and they are often misunderstood. Gray eyes contain even less melanin than blue. But instead of scattering just blue light, they scatter multiple wavelengths. which creates that metallic, almost silver appearance. They can shift between gray-green, even slight blue depending on lighting. But unlike other eye colors, gray eyes tend to feel neutral, calm, almost unreadable. There's less variation for the brain to interpret emotionally, which is why they're often associated with composure, control, even mystery. But biologically, there's a trade-off. Less melanin means less protection, which makes lighter eyes more sensitive to sunlight. Now, let's talk about one of the rarest and most fascinating: green eyes. Only about 2% of people have them, and they are not simple. Green eyes are the result of multiple genes working in perfect balance. Too much melanin? They turn brown. Too little? They turn blue. Green sits right in the middle, and it includes something else, a pigment called lipochrome. When light hits this combination, produces that unique green tone. But here's what makes green eyes different. They are dynamic. They don't stay the same. In low light, they may look darker, almost moss-like. In bright light, they can appear vivid, almost glowing, sometimes even shifting toward hazel or gray. This instability is what makes them so noticeable, so hard to ignore. Historically, green eyes have been linked to mystery, intuition, even supernatural traits. But evolutionarily, they may represent balance. Enough melanin to protect, but not so much that it limits light sensitivity. Adaptable, flexible. Now, let's talk about the chameleon of all eye colors. Hazel. Hazel eyes don't follow rules. They change. Genuinely. Not illusion. Not perception. Actual interaction with light. Hazel eyes contain moderate melanin, combined with lipochrome, but unevenly distributed, which means different parts of the iris respond differently depending on lighting. So one moment, they appear green, the next, golden, then brown. Hazel eyes are built for variation, for environments that change. Sun, shade, shifting seasons. They are versatile, adaptable, and no two hazel eyes are exactly the same. Now let's move to something even rarer. Amber eyes, often confused with hazel, but completely different. Amber eyes are golden, not shifting, not mixed, a solid, a copper-like color. This comes from high levels of lipochrome with very little melanin. And interestingly, this eye color is common in predators. Wolves, owls, eagles, which may be why humans instinctively associate amber eyes with intensity, focus, presence. Unlike hazel, amber eyes don't change with lighting. They stay constant, bold, unmistakable. And finally, let's clear up a myth. Black eyes, true black eyes, don't exist. What appears black is actually extremely dark brown, so saturated with melanin that it absorbs almost all visible light, which makes the iris look completely black. But this extreme concentration has advantages: maximum protection, minimum glare, stable vision in intense environments, which is why very dark eyes are common in regions with strong sunlight. Africa, South Asia, Southeast Asia. This is not coincidence. This is adaptation. Now, take a moment. Think about your eyes again, because what you're looking at is not just appearance. It is history. It is survival. It is biology still working inside you right now. Your eyes reveal how your ancestors lived, where they moved, what they faced, and how they adapted. This is not just about color, it's about design. And the next time you look into someone's eyes, you won't just see color, you'll see a story. And maybe, for the first time, you'll realize your body has been speaking to you all along. You just needed to understand the language.